Now we turn our attention to the specification of the various broadcast abstractions. So let us look first to best ever broadcast. So the instance is called BEP, and we have two events: a request event to broadcast a message, and an indication event to deliver a message from the source. So the interface would look like this. Here is our BEP abstraction, and we have broadcast M, and we have deliver M. And now we look to the properties of the abstraction, which are, as we know, safety and liveness properties. So best ever broadcast, let us look at the specification. And the idea of the properties of the best ever broadcast is basically saying everything is perfect unless the sender crashes. So what are the properties? The first property, we call it validity. So if PI and PJ are correct processes, then any broadcast by PI is eventually delivered by PJ. So as long as the sender is correct, so any correct process will deliver the message. Second, we know this from our study of channels earlier. We have no duplication. No message is delivered more than once. And we have no creation, which is no message delivered unless it was broadcast. So we know now the properties. So let us just practice these properties a little bit. So here is a situation where we have again 4 processes: P1, P2, P3, and P4. And this is a trace of an execution. So P1 did broadcast a message M. The message M is delivered to P2 and to P4, but it is not delivered to P3. Is this behavior allowed by the specification of a best ever broadcast? The answer, of course, is no. Why? Because validity says if the sender is correct, any correct process will deliver the message. And here's a case where our P3 did not deliver the message. So let's look to this example. And we ask ourselves, is this behavior allowed or not? So what do we have? We have P1 broadcast the message and then crashed. P2 delivered the message, P3 didn't, and P4 delivered the message. Is this behavior allowed? And the answer is what? Yes. And why is that? Because the sender has crashed, and our validity just talks about correct senders. So everything works fine with best ever broadcast as long as the sender is alive and well. But best ever broadcast gives no guarantees if the sender crashes. So reliable broadcast strengthens this form of broadcast to give guarantees even if the sender crashes. And what is the idea behind reliable broadcast? It is the same as best ever broadcast, plus basically the following condition, which says if the sender crashes, so let's ensure that all or none of the correct processes or nodes get the message. So here we are saying that even if the sender crashes and some process delivers the message, then all other processes will deliver the message. Or if none deliver the message, that's fine. So we are talking about the failure of the sender here. So again, we have the interface as usual. with a request to broadcast a message, which is a request event, and an indication event to deliver the message. And we have 4 properties. The first 3 properties are the same as the best ever broadcast. We have validity, no duplication, and no creation. But we have this extra property of reliable broadcast, and we call it agreement. And what does it say? It says if a correct process delivers a message M, whatever this process is, then every correct process delivers the message M. Now, if we look carefully, we will find that what we have defined now is we have taken the best ever broadcast 3 properties, these properties, and we added an agreement property. But in fact, the validity of best ever broadcast and the agreement property that we just added overlap. So we can make these 2 properties separate as follows. We can weaken the validity of the reliable broadcast as follows and say, if a correct process PI broadcasts a message M, then PI itself delivers the message M. Now, if we take this validity, the new validity, we call it reliable broadcast validity, which is of course weaker than the best ever broadcast validity, because reliable broadcast validity talking about PI only, whereas best ever broadcast validity talking about all correct processes. So now, if we take the reliable broadcast validity and the agreement property that we just says, if a correct node delivers, then all correct processes or nodes deliver, then we can see that these 2 properties together, in fact, implies the best ever broadcast validity. And here how you can think about it. So the reliable broadcast validity plus the agreement implies the old best ever broadcast validity. For example, assume that PI is correct. By the reliable broadcast validity, PI delivers M. Now, assume PJ is also correct. By the agreement property, because PI is a correct process, then PJ also delivers the message. So now we have the best ever broadcast validity property. So, as you can see, the old validity condition now is equivalent to the new validity condition when we have the agreement property. So let us look to examples to practice these properties for reliable broadcast. So here is a situation where P1 broadcasts a message M and then crashes. P2 to P4 did not deliver any message. Is this allowed? The answer is yes, because reliable broadcast ensures delivery only when correct processes deliver. But here we have a situation where no process at all deliver. So here is another example where P1 broadcasts a message and then crashes. P4 delivers the message and then crashes. But P2 and P3 did not deliver anything. So is this allowed? The answer is yes, because the agreement property says if a correct process delivers, then all correct processes deliver. Here we don't have any correct process, so P2 and P3 are not obliged to deliver anything. What about this example? P1 broadcasts a message, P4 delivers the message and then crashes, but P2 and P3 did not deliver the message. So is this allowed? Remember, P1 is correct. Therefore, by the validity of reliable broadcast, P1 will eventually somewhere here deliver the message. So it will deliver the message from P1, the message M. And therefore, because P1 delivered the message, P3 and P2 are obliged to deliver the message, so this behavior is not allowed. What about this then? P1 broadcasts the message and delivers the message. P2 delivers the message, it is correct process. P4 delivered the message. P3 did not deliver the message and it has crashed. Is this allowed? Yes. A crash process is not obliged to deliver a message. This is not part of the specification. So now let us look to a strengthening of reliable broadcast to something that we call uniform reliable broadcast. And you will see what this means. Uniform reliable broadcast has to do with processes that delivers a message. The message is sent to the application, and the application did some side effect on the external world. And then after that, the process died or crashed. So this is what uniform reliable broadcasts want to address. So let us discuss this. So let's assume a sender broadcasts a message. The sender fails. No correct processes delivers a message. Okay. Some of the failed processes deliver the message. So here is the situation. Here is a process. So this is the broadcast abstraction, BR. This broadcast abstraction is connected to an application. And I will call this application external world. Okay. This process, let's call it PI. It delivered the message M. So it did a deliver. And then it crashed. Of course, the external world, which is the application, continued to do something with this message. So, for example, assume this application will enforce printing of a message on a paper or withdrawing money from an account or informing a set of agencies about stock values and so on. Is this okay? This is the question. Is this okay? Do we want this behavior? Or at least we want all other processes that are correct will also deliver the message. So, and that is what uniform reliable broadcast tries to ensure. Uniform reliable broadcast intuition is that if a failed process delivers, then every possible process should deliver. However, we can only guarantee that at least correct processes should deliver because we cannot revive dead processes. So this is the basic idea. So a uniform broadcast says simply like that. If a process delivers, whether it crashed later on, every correct process should deliver. So the events is as usual, a broadcast and deliver. And the validity, no duplication, no creation is the same. But now we have uniform agreement. A uniform agreement says for any message M, if a process delivers M, then every correct process delivers M. Whereas reliable broadcast that is not uniform requires if a correct process delivers M, then every correct process delivers M. So that is what we said about dead or alive.